Ah, that's a pretty good start, wasn't it? Hmm. Scientists has obtained two arrays A and B containing n and m elements respectively. For each integer I, one to n, he is allowed to perform the operation at most once. Choose an index integer j such that it's less than n, and note that AI may become non-positive as a result. So, as a result of this operation, student need to determine whether he can sort A in non-decreasing by performing the above operation some number of times. Hmm, that was the easy version. And if I copy that, paste over here, and put 2 here. The only difference is the m value of n. Here the value of m is 1. Hmm. We will um, we will choose an index j. Okay, for every element we choose an index j and set ai to bj minus ai. Okay, so what we are doing here is let's say let's take an example. Ah, that was so weak. Let's take that one. Okay, so let's comment that. Let's comment that. Okay, so let me see. N value is 4. That means 4 elements are there, and one is one always. M value is always 1 for the easy version. So let's see what he chose. Uh, which one? Fourth one. Fourth one is not available. Mm, then let's go with this one. Okay. So what we have is 4 and 1. 4 elements and m equals to 1, and it chooses mm, b1. It chooses b1. B1 is hmm. Yeah, you don't have that many choice for that. Let's go for the hard version, because if you solve the hard version, then it's uh, both problems are equivalent. If we solve C2, then it's equivalent to C1 also. So um, let me just check, is my voice clear? Let's see. Okay, the voice is clear, so that's not a problem. Let's continue with this problem. Um, okay, let's take a test case from here. We have two arrays here. We just have to output yes and no. That means if we are able to sort the given array in non-decreasing order. Hmm. We are continuously subtract. Okay. All right. All right. All right. Then what we are doing here is we select an element from the array B and change the AI to bj minus AI. That means what could be the best approach to choose bj? Hmm. bj. bj. Hmm. bj. Let's see how they did that. Let's go through third test case. And third test case is we choose b1 and b1 will convert to equals to 4, right? b b1 minus ai, what? We can set a2 to, hey, hmm, this doesn't tell us, wait a minute, at most. Okay, so it means that okay, so it is not necessary to do a operation every time. We can just skip that. So if we can just skip that, then we traverse the array and find that element. um, I mean stop on that index which is smaller than the previous one. Yeah, strictly smaller than the previous one. And if we got some, uh, we will we will take a number, a larger number, which can. Hmm, 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 hmm. Okay, we can choose a number which can increase it, which can increase its value just a little, uh, just a little from the previous one. Okay, and we have to choose the minimum element. Okay. So if we sort the array B and we found the lower bound. Okay, got it. So let's just clone this second problem instead of the first problem. Where is the extension? Yeah, there it is. Okay, let's open the C++ file and no, template multi-one. So Okay, and that's the B. Um, okay, let's copy that. SAA, and after taking both the input, we just have to sort the array B. So let's sort the array B and let's traverse the array. Okay, let's traverse the array. Hmm. Array A, and we what we have to find is just we just have to find the lower bound of what is that AI. We will minus the AI from that BJ. Hmm. So let auto IT, or you can say lower bound. Lower bound should be equals to lower bound all of the B, and we find A of I plus I think should be should we make it smaller? Okay, we will make it smaller, but from now we just start from the index one. Okay, then A of I plus A of I minus 1. So that's the index we need. If LB is equals to B dot n, then we just return with a no. Then we just return with a no, and otherwise we will continue. We will continue that algorithm. So I think we have to update the AFI. AFI should be star LB minus AFI. That's it. And let's just see out yes. And the one thing is just we have to decrease the first element as much as possible. So let's take the minimum element. So let's take AI A0 equals to B0 minus A0, or we can say min of A of I mean A of 0. Okay, and this whole operation only we do this only operation if we found an element smaller than the previous one. So if this current element is smaller than the previous element, then we search for the element. Otherwise, we didn't need to do anything. Right. So let's test that. Got wrong answer for the third test case. So third test case. Okay. This is the first one. I mean, this was the first one. This is the second, and this is the third one. So third one got wrong answer. Third one got the wrong answer, and let's see why. Why we outputting the no? Hmm. So we have 2, 4, 6, 5. So what we did is, wait a minute. Let me just output the debug. Let me just output the value. Output the value of what it is, a. Okay, let's see. It's -4. That's it. Got it, got it, got it. Because we are exiting the function for no. So let's write it here before sending any no message. So these messages are only for the no ones. So this is the okay. We made it -1. So -1. Can we make that -1? There's the third one. So we take no, not that one. This is third test case. So we take one and it okay. So it could be -1. That means then what we do? We have a 4. So wait a minute. I think we should do that for all of the elements, not for the decreasing ones. Let's see. Okay, you got accepted. Okay, let's try that. That was the second one. Let's see. Oh, you got wrong answer. Should we see the test case? Let's just not look the failed test cases. Um, it's wrong answer on test 2. Mm, could it be overflow? So what we can do is just transform every int to ll. gc. Yes, 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 yes. Okay, perfect. Let's run again and submit again. Let's try to submit again and let's see if that's the problem. Codeforces is super slow as always. Oh, come on. Let me just work a dryer in my code. Hmm. Okay, that's the minimum element for sure. And this is AI plus AI minus 1. Okay, shouldn't be any problem with that. Running on test 1. Why? Why it's taking so long? I mean, why? I mean, running process shouldn't take so long because it's just um, n log n order of complexity, I think. Okay, we got some wrong answer again. Alright, then what to do? What could possibly go wrong? Hmm, we can sort B for sure. Okay, we take the input correctly and we reduce the zeroth element as much as possible. What if the BI could be negative? No, no element is negative initially. So no element is negative initially. That means this that B0 will be the minimum element, and we minimize it by the original value. So don't have problem with that. Then what we do, we take a lower bound of previous element plus the current element because we gonna subtract that. We subtract that element and okay. Uh, 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 uh. No, 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 no. Okay, we need the value at least a of I minus 1, and we will subtract a of I from it. Then okay, that's correct. So hmm, what could be the problem? Hmm, this is a of I equals lower bound minus a of I, and at the end we return yes, but it's not working at all. It's not working at all, then what could be the answer? What could possibly the answer? Anyone have some hints? What is wrong with this code? I mean, we just sort the array B and reduce the first element of array A as much as we can, and we are doing by taking the minimum element of B and subtract A0 from it. So we have the first element as minimum as possible. Then we start from the first index and we found the lower and we found a we will find a lower bound for AI and AI minus 1, uh, and if we found any, then okay, if we didn't find any lower bound, then we return the no because we can do that. And if we found it, then we update the value of AI. That's crazy. And if the whole loop is executed successfully, then we return the yes. Then what could be the problem? We are dealing with the hard version because if hard version passes, then C1 also passes. Hmm. That's the worst part of competitive programming, I guess. I mean, I think just a little off from the answer, and it take so much time to figure out where you messed up. Hmm, how are we gonna do that? Do we need to find a unique value? No, it's not possible because if the m is less than n, then okay, okay, that's not possible. Okay, okay, okay. What could be the issue? What could be the issue? Lower bound should work, I think, because we need the current element to be equal to at least equal to the previous one. So we take the previous one, add the current one, because at the end, what we will do, we subtract it, subtract the AI from it anyways. Then, then what could be the problem, man? And we sort the array B already. Then what could be the problem? Okay, let's look out the test where we are failing because I don't have any idea we are where we are messing around. What? I can't inspect that. This is 3416th token. Man, oh man. Uh, it's not possible to get that test case. Well, well. We can do a stress testing to find out the test case. But we need a solution for that. We need to write a slow solution. Hmm. But this is a very basic question. I mean, I don't think stress testing is worth for. I mean, this question is not worthy for stress testing. Hmm. We need at least previous one and we add that. So it will become at least greater than. Okay, let's debug that. Let's see the shape of outputted outputted array and okay, this is the first one, this is the third one. Third one is negative 1, 2, 2, and 3. Negative 1, 2, 2, and 3. Hmm, it's negative 1, 2, 2, and 3. It's correct. Then we have negative 1, 0, and 1. Looks promising to me. Then what is the problem with you? Man, what is the problem with you? We didn't changing any value in the B, so everything should be fine. Hmm. Okay, I think it's enough time for this problem. We can take a little hint from the tutorial and let's see where we can messed up. Let's see C2. No, the code, not code, the solution. So overall idea for both subtasks is that you need to iterate from left to right. Here we are doing that. And upon each element, pick the operation such that we obtain the smallest value of AI that is greater than the AI minus 1. Makes sense? For C1, no, for C2, you have m values in the array B. Clearly, we now need to consider m plus 1 different possible values per index of A. Solving this problem in is clearly too slow. Therefore, we need to employ a different technique. Note that instead of trying every value, you can sort the all elements in uh, all the values in M. Yeah, this is what we are doing here. And then binary search for the minimal value bj such that bj minus ai is greater than equals to ai minus 1. Well, let me tell you something. This is what we are doing here. So you telling me bj minus a of I guess, should be greater than equals to what it is, ai minus 1. So this is equivalent to let me write it here. So this is equivalent to bj. We look for the bj which is greater than equals to a of I minus 1 plus a of I. And this is the same condition that we are writing here. This is the same condition. We're taking the lower bound for ai and ai minus 1. Hmm. And this symbol, uh, this uh, this symbol is for the lower bound. This symbol represents the lower bound. Then why it's not working? And yes, the time complexity is n log m. Okay, now what is this? What? What? I don't have any clue. I literally don't have any clue. What is this, man? What do you mean by negative 15? Hey, what does negative 15 means? Anyways, negative, let's say negative 15. Oh, no compilation errors. Let's see the definition of this lower bound. Okay, finds the first position, which value could be inserted without changing the ordering. Okay, binary search algorithm. First an iterator to okay start, then we end, and the value to search, and the comparator function. Hey, wait a minute. Why it's sending negative 15 here? That makes no sense. Result b equals to negative 15. Well, it will never be negative 15 because the b value is always a positive value. So you are telling me that we should. This is the waste value, I think. you passes regardless of what is the searching value is. So I think we should pass a comparator also. So let's pass a comparator, LLA, LLB, and let's just return the, let's keep some spacing here. Return A. We have A and B, right? A minus, okay, okay. So this is a vector of A. We subtract the value of vector AI from the A value. And what is A here? Okay, A is simply here. Hmm. Hmm. So if we subtract A of I from this, and this should be greater than equals to what we have in B of. Hmm. Oh. Wait a minute. This is X. This is Y. This is X. And why we didn't use Y? Let's run that. And it got wrong answer. Okay. Oh. Let's go back 1 second. And you can see here in this code, they are continue moving forward. What? Okay, now I got it. Where we have the bug. We just have to continue the process because I got it. Because if that value is already bigger than the previous one, we don't need to find the lower bound. I'm so dumb. In the last one, we just have to check if the array is sorted or not, and we can do that by just is sorted all of the array A, all of the array A, and yes, if sorted, no, if not.